After reading Essential Calculations for Veterinary Nurses and Technicians, 4th edition, Chapter 10, you will be able to go through a question and determine the mean, the variance, and the standard deviation of a data set. If you have the 3rd edition, you will find this information in Chapter 18. Before we go ahead and do our question, let's do a brief run-through. What is the mean? So the mean is the average of a set of values. We add up all the values and divide by the number of values, as you can see in this equation here. This symbol here is the sum of, which means we're going to add together x, and x is the values in the data set. N is the number of the values. Now, what is the variance in question? The variance is the measure or the spread of the data. Essentially, how far the data is spread from the mean. And you can see that in this calculation here. Finally, standard deviation. What is standard deviation? It is the average of the variations from the mean. It allows us to determine if a value is considered abnormal by determining how far from the mean it is. As you can see here, the mean is in the center if you're picturing a bell curve. And when we're figuring out standard deviations, one standard deviation falls equidistant to the mean as such. And you can see that here as an equation. So let's go through and do a couple questions, or one. So here we have blood glucose values of 21, 19, 7, 5, 9, and 11. The first step we're going to do is determine the mean. So determining the mean, we are going to add together all of these values here. So 5 plus 9 plus 7 plus 11 plus 19 plus 21. And that's going to equal, divided by 6, because we have 6 values in the data set. So the sum of these values divided by 6 gives us a mean of 12. So we can write that here. So 12 is our mean, and you can see the mean is shown by x with a line over top of it. So we can go ahead and put our mean in here as such. Okay. The next step is we're going to determine the variation from the mean. So the variation from the mean right here is what we're going to determine. So what we do is we go 5 minus 12 to get our value. So 5 minus 12 gives us negative 7. 7 minus 12 gives us negative 5. 9 minus 12 gives us negative 3. 11 minus 12 gives us negative 1. And 19 minus 12 gives us 7. And 21 minus 12 gives us 9. Now, as you can see, we have both negative and positive values here, and we need to change that so we have all positive values. So the next thing we're going to do is we're going to square the variation from the mean. So here, you can see we're going to do this right here. So essentially what we do is we go 7 squared, or negative 7 squared. It's going to change this into a positive to give us 49. 5 squared gives us 25. 3 squared gives us 9. 1 squared is obviously 1. 7 squared again is 49. And you can see we had both a negative 7 here and a positive 7 here, and it ended up with the same for us, with being a positive of 49. And then 9 squared gives us 81. So the next step is to find out what the sum of the square of the variation is. It sounds fancy, but all we're going to do is we're going to add the values right here in this data set here, which is the square of the variation. So we go 49 plus 25 plus 9 plus 1 plus 49 plus 80, and that is going to give us 214. So this is the sum of the square of the variation. So to find the variance, what we need to do is we need to take this value right here, and we need to divide it by the number of values in the data set minus 1. So that equation then looks like here, the sum of these and n minus 1. So that becomes 214 divided by 5, which gives us the variance of 42.8. Now we haven't figured out the standard deviation yet, but we're almost there. To figure the standard deviation, we need to take the variance and we need to square root it. So we go 42.8, and the square root equals 42.8 squared root equals 6.5, and this is the standard deviation. So the standard deviation now looks like S2 squared, essentially, which is right here, to give us a standard deviation, as we can see right here. So 6.5. Now how do we determine, or which values fall outside of that standard deviation? If we picture our bell curve here, we can see in our calculation we said that the mean was 12. So the mean would fall right in the center here. And the standard deviations are these sections right here. And because we determined the standard deviation to be 6.5, any value that falls greater than or less than 6.5 points away from 12 would be outside the standard deviation. So in our example here, we can see that 21, 19, and 5 fall outside of that one standard deviation, because we said 12 was the middle, so it would be 6.5 points away from this and 6.5 points away from this. So anything greater than 18.5 or less than 5.5 would fall outside of that standard deviation. And as we can see here, we've got 5 would be on this side, and 19 and 21 would be on this side, and they would fall outside of those standard deviations.